Okay, so now we start to get into some of the fun stuff. So today we are going to be talking about standard deviation. Let's see if I can get this a little bit closer, maybe make that a little bit clearer for you. Okay, so we're talking about standard deviation. First off, this is from lesson 4, which we already did. Lesson 4 showed us this battery life and said, okay, what is the mean? Well, the mean for this example was 101 hours. So this right here was my mean at 101, okay? Could we figure that out again? Sure, but we're not going to. We didn't really in the last one. I just kind of told you. The mean, remember, we add everything up, we divide by the number of numbers. So the question is, how can we find standard deviation? So standard deviation is really telling me what things should be averaging away from something. Okay, so when I look at test grades, I have standard deviations. If you're within one standard deviation, that means you're within the one average. Okay, so as I take a look at this, to do standard deviation, how do you measure variability of the set? Again, one way is to calculate standard deviation. So why is that still up there? Let's see if I can get that away. Oh my goodness. First, find each deviation from the mean. Remember, we learned deviation in lesson 4 was our x minus our x hat. X hat was our mean, so I take 83 minus 101, I get negative 18. You're going to do this for every single data point. It is extremely imperative that you do this for every single data point. So we have 83, 94, 96, 106, 113, 114. We have to find the deviation first. 83 minus 101, 94 minus 101, 96 minus 101, 106 minus 101, and so on and so forth. This is the deviation. This is from lesson 4. That's what we worked on in lesson 4. But we need to go another step. To start to begin to find the standard deviation, we need to square each deviation. Okay, we need to square it. That means that I'm taking this and I'm going to square it. When I square a number, it's going to be positive. So even though it's negative 18 squared, it's negative 18 times negative 18, which is 324. Negative 7 squared, 49, negative 5, 25, 525, so on and so forth. Okay. So we have our first step. We have our second step. Our third step is to add up all of the square deviations. So we're only adding these guys. So it shows us we had 324, 49, 25, 25, 144, and 169. This result is the sum of the squared deviations. Okay. Whew. So we're trying to find out what one standard deviation is. We've got a couple steps. So we added them. Now we need to start to find the average for it. So you divide by the number that you found your mean minus 1. So we're taking 736 minus however many numbers there were minus 1. And they call it n. So n minus 1 gives me 5. So notice there's 6 numbers. 1, 2, 3, 4, 5, 6. We are now taking 736 and we're dividing it by 5. So here's step 4. So if you're keeping a list of steps, which I'm going to do here in a second, you're going to want to have this. Finally, you take the square root of that division. And this is the standard deviation. Well, what does this mean? This number means that the average battery should be somewhere between 104 plus 12 and 1300ths and taking away 12 and 1300ths. Somewhere in this range are where all of the average batteries should be. That's what would be considered a consistent thing. So how do we do this? Well, one more time, let's write down the steps and I would have these steps written down. More often than not, your calculator is going to do it, but for this lesson, we're doing it by hand. So the first step is we are going to find the mean. Second step, we find deviation. And deviation is the data point minus the mean. That can be both positive and negative. Then we square each deviation. So really, in essence, you're taking x minus x prime, whatever, or x hat, and you're squaring it. Okay? Because I did 83 minus 101, and I squared this number. Fourth, add all squares together. Okay? We're going to add up all of these squared deviations. Fifth, we divide by, or let me try this again. We take the sum and we divide it by n minus 1. So however many data points you have, you subtract 1 and you divide. Last but not least, take the square root of, I don't know what that's supposed to be, this answer. Okay, that's how we're going to find standard deviation. I promise you, there's an easier way in your calculator, but right now they want you to do it. So this is the standard deviation. And then it starts talking down here. That is the standard deviation. It's even put an exclamation point. It talks like I do. It seems like a very complicated process at first, but you will soon get used to it. You know why you're going to get used to it? Because the calculator is going to do it all for you. We conclude that a typical deviation of a battery from the mean is 12 and 1300ths hours. The unit of standard deviation is always the same as the unit of the original data set. So if we're talking about hours, it's going to be hours. If we're talking about percent, which I do a lot with your grades, we're going to keep it as percent. How close is the answer to the typical deviation that you estimated at the beginning of the lesson? Well, we're not worried about that. Okay. So we're going to do one of these together. So now you can calculate the standard deviations of the lifetimes of the 8B batteries. I'm going to leave this over here. Let me get a calculator. I didn't come prepared, obviously. And let's see what we're going to do. So they already did the deviation. How did they do that? They took 73 minus 101 and 1 and 5/10. So they did that for all of these. 76 minus 101 and 5/10, so on and so forth. That's how they found the deviation. For this, I'm taking 27 and 5/10 and I'm squaring it. That gives me 756. Sorry guys, I'm a little off. 56 and 2500ths. 24 and 5/10 squared gives me 600 and 2500ths. 8 and 5/10 squared gives me 72 and 2500ths. 6 and 5/10 squared is 42 and 2500ths. 9 and 5/10 squared is 90 and 2500ths. 16 and 5/10 squared, 272 and 2500ths. 17 and 5/10 squared is 306 and 2500ths. And last but not least, 23 and 5/10 squared gives me 525 and, oh man, come on, Miss Rach. It's Friday, get your stuff together, and 2500ths. So now I've done step one, the square deviations. I'm not going to go, I'm just going to keep on going with my own thing. So now we're going to add 756 and 2500ths plus 600 and 2500ths plus 72 and 2500ths plus 42 and 2500ths plus 90 and 2500ths plus 272 and 2500ths plus 306 and 2500ths plus 525 and 2500ths, and that gives me, so the sum is 2665. And yes, I'm going to go to my answer key, and yes, I'm going to double check because it's telling me that I'm wrong. What did I not do correct? 756.25. Good. 625. 72.25. 42.25. 90.25. 272.25. 306.25. Why am I getting a different answer than the book? I'm going to add it one more time. 756.25 plus 600.25. 72.25. 42.25. 90.25. 272.25. 306.25 and 525.25. I'm still getting the same number, and they are not. They're saying it's 26.92, and I'm just not getting that at all. 552. Oh, wait. Maybe I wrote down the wrong number. Let's see. 23 and 5/10 squared. Oh, I did write down I did an inverse. It's Friday. This is 552 and 2500ths. This is why we double check our work. So I did 23 and 5/10 wrong. That's my fault. So let's add it one more time. So let's go 756 and 25 plus 625 plus 72 and 25 plus 42 and 25 plus 90 and 25 plus 272 and 25 plus 306 and 25 plus 552 and 25. Now I'm getting the right answer. There we go. So the sum of the squared deviations is 2692. Holy moly. From here, we count 1, 2, 3, 4, 5, 6, 7, 8. So my n is 8. So the next portion is I take 2692 and I divide it by 8 minus 1, which is really 2692 divided by 7. So now I take 2692 divided by 7, and I'm going to get a division of 384, and I'm going to round it to 57 hundredths. Okay, so now we're here. The last step to find the standard deviation, the last step is I have to take the square root. So standard deviation is now going to be 384.57 second x squared. That, I don't know if you can see that, but that gives me my little square root symbol in there. So now I go 384 and 57 hundredths. I press enter, and I get something that is, and I'm going to show you, this is the approximate symbol, 19 and 61 hundredths. This is the standard deviation. What this means, oh my goodness, I screwed this all up, guys. You should have stopped me in the video. I put 101, it should be 100.5. Shoo, it's been a rough day, clearly. So I get 19 and 61 hundredths. What this means is, if I go at 105 tenths and I add 1961, that puts me at 120.1, something like that. This is within a standard deviation. This is within a standard deviation. This is within a standard deviation. This is outside of that one standard deviation. I can do the same thing if I take it away. So if I do 100.5 minus 19.61, 100.5 minus 19.61. Come on, Mr. H. That puts me down to 80 and 89 hundredths. 0.5 plus 19.61, 120. So this is considered one standard deviation. So all of these, this is within a deviation. This. Not within a deviation, not within a deviation, not within a deviation. What does that mean? That means those are outliers. Those are bad ones. We don't want those. Okay? This is how we're going to find standard deviation. That means, again, what deviation means is that's about average. All of these are within the correct average. If they're not in the correct average, they are considered an outlier. Within that one standard deviation, we're A-OK. So standard deviation has 5 steps. Let's see if I can bring this closer. I don't think I can. Step 1, find x hat. What is x hat? Well, that's just my way of calling the mean. Then we find the deviation. We take our data point. We subtract the mean. It could be both positive and negative. We square each deviation. Whatever positive, negative, we're going to get a positive. We add all those squares together. We take the sum, which we just added, and then we have to divide it by the number of points. In this case, there were 8 data points. Okay? We subtract 1, so that's 7 for this one. but we subtract 1 and we divide. That gives us an answer. Whatever the answer is, we take the square root, and that is my 1 standard deviation. I personally like standard deviation. I use standard deviation a lot when I'm trying to see, okay, how did I do it, like teaching-wise? So if I've given you a test and your test scores all over the place, I want to see, okay, where is the majority of you scoring? That's what I use standard deviation for. We'll work on this in class. Have a wonderful, safe day whenever you're watching this. Where's my mouse so I can shut this off and you don't have to look at me? Bye.